Good evening, this is Kavipriya, Assistant Professor, EC Department. I am going to deliver a topic quantization. So first, what is a quantization? So digitization of analog signal involves a rounding of the values which are approximately equal to analog values. The method of sampling chooses a few points on analog signal and then these points are joined to round off the value to near stabilized value. Such a process is we called as a quantization. The analog to digital converters perform this type of function to create the series of digital values out of the given analog signal. The figure that is shown in the figure is an analog signal. This signal is to be converted to digital, has to undergo both sampling and quantizing. The quantizing of analog signal is done by discretizing a signal with a number of quantization levels. Quantization is representing the sampled values of amplitude by a finite set of values, which means converting a continuous amplitude signal into a discrete time signal. The following figure shows a analog signal gets quantized. The blue line represents an analog signal while the brown line represents a quantized signal. Both sampling and quantization results in loss of information. The quality of quantizer output depends upon the number of quantization levels. The discrete amplitude of quantized output are called as representation levels or reconstruction levels. The spacing between two adjacent representation levels is called as a quantum or step size. The figure that shows a resultant quantized signal, which is a digital form for a given analog signal. This is also called as a staircase waveform because it is in staircase shape. There are two types of quantization. The first one is a uniform and second one is a non-uniform. The type of quantization in which the quantization levels are uniformly spaced, we call it as a uniform quantization. Whereas in case of non-uniform quantization, the quantization levels are unequal and mostly relation between them is a logarithmic. There are two types of uniform quantization. They are mid-rise and mid-thread. So the figure shows a mid-rise and the mid-thread type of quantization. The mid-rise type is also called as a mid-rise because the origin lies in the middle of rising part of a staircase-like graph. The quantization levels in this type are even in number. The mid-thread type is also called as a mid-thread because the origin lies in the middle of thread of the staircase-like graph. The quantization levels in this type are odd in number. Both the mid-rise and mid-thread type of uniform quantizers are symmetric above the origin. Next is a quantization error. For any system during its functioning, there is always a difference between the value of its input and output. The processing of a system results in an error, which is a difference between those two values. The difference between an input value and its quantized value, we call it as a quantization error. A quantizer is a logarithmic function that performs quantization, which is nothing but a rounding of the value. The analog to digital converter works on a quantizer. The figure shows an examples of a quantization error indicating a difference between a original signal and a quantized signal. And next is a quantization noise. It is a type of quantization error which usually occurs in an analog audio signal while quantizing it into a digital. For example, in a music, the signals keep changing continuously where regularity is not found in the errors. Such errors create a wideband noise called quantization noise. And the next is a compounding in a PCM, pulse code modulation. The word compounding is a combination of compressing and expanding, which means that it does both. This is a nonlinear technique used in PCM, which compresses the data at the transmitter and expands the data at the receiver. The effect of noise and crosstalks are reduced by using this technique. There are two types of compounding. They are ALA compounding and MULA compounding. In case of ALA compounding technique, a uniform quantization is achieved at 1A is equal to 1, whereas the characteristic curve is linear and no compression is done. ALA has midrise at the origin, hence it contains a non-zero value. ALA compounding is used for PCM telephone systems. And next is a mu law. Uniform quantization is achieved at mu is equal to 0. where the characteristic curve is linear and no compression is done. Mueller has a mid-trade at the origin, hence it contains a zero value. Mueller compounding is used for speech and music signals. So that's all about the quantization. What is quantization and what are all the types of quantization and what is a quantization law and what is a quantization error, and we have seen it's a compounding technique also. So that's all about the quantization. Thank you.